Good evening, everyone. In the last session, we discussed about volumes concept in the Docker. Docker volumes are used to persist the data generated by Docker container. So whenever a Docker container started, it will write some data to the container that is stateless. That means whenever you stop the container, then you are going to lose that data. So if you want to make your application as a stateful application, what is the meaning of stateful application? Even after Docker container got stopped, I don't want to lose my data. I want to save my data. Even after Docker container got stopped, I want to save my data. I want to maintain my data. That you need to go for volumes concept. So volumes are used to store container data permanently. Docker volumes are used to store or persist the data generated by Docker containers. Using Docker volume, we can decouple data storage from Docker container. Using Docker volume, we can share the data among multiple Docker containers. Yesterday, we have seen the lab also. I have created one file in one container and I have shared that file with the another container by using volume concept. So whenever we have a Docker volume, we are going to attach that volume to the Docker container. So container data will be stored to the Docker volume. Even after you delete that container, even after deleting that container, Docker volume will not be deleted. So how to work with volumes? We have seen several commands in the last session. In order to create a volume, so we have a option called Docker volume create. Docker volume create volume name we are going to specify. Docker volume create and volume name. Docker volume ls, so which is used to list down the Docker volumes available. Docker volume inspect to see that particular value. And if you want to remove that value, Docker volume rm command. If you want to remove all the unused volumes of the Docker, then we will go for Docker volume prune command. So these commands we have experimented in the last session, and I have given some lab task also for the Docker. Now guys, here in the yesterday session, when we are using the Docker volumes, so I have created a volume by using Docker and I have pointed that to the particular destination. So whatever the data that is available in this destination will be mounted to this value. Even after that container got deleted, that data will be available in the value. So that is what we have practiced in the last session. Are you guys able to practice the commands which I have given in the order? Pulling a Docker image nginx, running the nginx in one container. For the container, we are giving some name. Then I'm connecting to that container and I'm modifying the data in the index.html. So I'm making the changes to that particular file in the container. Then I'm accessing that website. After this, I'm stopping that container. I'm starting another container. So when I make some changes to the index.html and when I try to run that nginx image in the another container, whatever the changes we made in the first container will not be displayed in the second container. There is no sharing. There is no sharing. So this is the problematic scenario. So that is the problematic scenario. So here up to now, we have seen the problem. First, I have started one container. I made some changes to that file in the container. Then I'm trying to access that in the second container. That is not possible by default. One container data we cannot share with the another container directly. It is not possible. So to share the data from one container to another container, we are using volume concept. So here I have created a volume, new volume. Now I mounted this volume to the container by giving the volume name. So here I'm giving the mounting. So Docker run command. I want to run this Docker container with a name and I am mounting. Mount source is a new wall. New wall is the volume name which we have created. Destination is this directory. So that means whatever the data available in this Docker container directory, that is mounted to new volume. So any changes you made in this destination location, that will be stored to new volume. Even after you delete this container also, the data will be available in the new volume. So that is what we are trying to achieve. Permanent storage of the data which is generated by that container. So after running this container, I'm accessing that container. Then I am making some changes to that container. After making the changes, then I'm stopping that. Then I am running another container. Another container is able to access the data which we have modified previously. So the data which I have modified in the first container, we are able to access that data in the second container. That means the data sharing is happening by using volume concept. So currently we have done the volume creation, that is a named volume. That is a named volume we created, and we mounted that named volume to Docker container. Sir, instead of mounting a named volume, can I mount one directory in the host machine itself? Here we are creating one host machine. We are creating one host machine. So this is our EC2 machine. In this EC2 machine, we are running Docker container. EC2 VM we are running. In this EC2 VM, we can say that Docker container is running. We are saying that Docker container is running. Can we mount Docker data to one directory? So here I'm going to create one directory. I want to mount this directory to Docker container. Earlier I used named volume. So today I want to go for binded mounting concept. That means I'm not going to create any particular volume today. Yesterday we created a volume and we created a value. We mounted that volume to the Docker container. So whatever the data is available in this directory will be stored to this volume. This volume is having a name that is called named volume. But today I don't want to go for that named volume concept. Whatever the data generated by the Docker container, I want to mount to a particular directory in the host machine directly. So this is a host machine directory which I want to use for this Docker container data. So I want to keep a connection between this directory in my host machine and the Docker container. Whatever the files I keep in this directory should be available for the Docker container. Whatever the files I keep in the Docker container, it should be available for this directory. So mutual understanding. I want to establish a communication. I want to create a connection between host machine directory and the Docker container. So whatever the data generated by the Docker container, that should be stored into this directory, or this directory data should be available for the Docker container. Are you guys clear with my point? So that concept is called as mounted volume, bind mounts, mounting the bind volumes, we can say that. Okay, so here what I am going to do is I'm going to create one directory. TMP in the temp root location, temp directory, nginx html. So I'm going to make one directory by using mkdir in my machine. So I connected to my Docker machine, Docker info, Docker is running, my present working directory /home/ec2 user. Present working directory I'm printing, I'm connected to /home/ec2 user. I'm creating one directory. Okay, by using mkdir, I'm creating one directory. Slash means it is going to start from the root location. In the root location, tmp nginx html, I'm creating one directory. Perfect. We can navigate to the directory also. We can see that cd space /tmp /nginx/html present working directory. So see here, tmp directory, nginx directory, html directory. So we created that directory. Okay. Now cd space home/ec2 user. So this is my present working directory. I just created one directory. Now here guys, I want to run one Docker container. I want to run one Docker container for nginx image. Docker run -t-d detached mode -p port mapping -v that value. So this is source location and this is destination location. This is name of my container. So I can say that as C1 container 1 nginx latest image I want to get. So it is going to run one Docker container with a nginx image. Whenever you give the image name for the run command, if this image available in the local, it will take this local image only. If the image is not available in the local, it will pull from the library. So we already discussed about that. So if you want to download the image first, you can download it by using pull command. Then you can give the image. Without downloading, if you directly run this, without downloading, if you directly run this, then it is going to download from the library. I'm running this container with a name called C1. My container name I'm giving as a C1. Docker run by using port mapping 8080-B. So if you see in the previous session, what I have given for mounting, I have given -mount source new volume destination. I have given the volume name, but today, am I creating any volume? Am I directly mounting to my local directory? Am I creating any volume today? Am I mounting to my local directory? Bind mounts. Are you guys getting my point? This -t is just to specify the name of it. We can ignore it. That's not a problem. When we are creating the image, we are giving -t option, right? So same option, we can ignore that. That's not a mandatory flag here. So you need to observe the difference. So whenever I am running a Docker container, what is the difference that we have seen in yesterday's command and today's command? I'm removing -t. That is not required. Here I'm giving the name as a C1. Okay, what is the difference that you observed between yesterday's command and today's command? Here it is used to run Nginx image only. It is also used to run Nginx image only. What is the difference you observed between yesterday's command and today's command? Come on. Any difference that you observe between yesterday's command and today's command to run a container? What is the difference you observed? The container name can be anything, man. Container name can be anything. Here I have given the container name as a web app. Here I have given the container name as a C1. Here I have given the container name as a web app 21. Here I have given the container name as a C1. Apart from that, what is the difference that you observe? In the yesterday's command, I specified named value. In the yesterday's session, I have specified a named value. But today, am I specifying any named value? Am I mounting to a particular directory? Am I specifying any named value? Am I mounting directly to my local directory in the EC2? I'm mounting to local directory. So here, if you want to persist the Docker containers data, we have two options. You can go for mounted directories or you can go for named values. Container is running. Container will generate some data. That data is temporary, stateless. So if the container got stopped, we will lose our data. Container running our application with stateless. So if the container got stopped, then we are going to lose our data. We are going to lose our data. I want to preserve the data. That means I want to store the data. So how many ways I can store? I can go for a volume concept. I can store that data, or I can go for mount volume concept. That means binded mounts. I can bind that data to my directory directly. So I created one directory in my machine. Then I am running the container. Here I'm specifying the location. This is my directory location which I have created, and this is Docker container location where Nginx will be running. Now container name I am giving as a C1. Container name can be anything. This is the image name I am giving. If this image is available in the local, then it will use it. If it is not available, it is going to pull that image. Copy this, run the container. Unable to find the Nginx locally, so it is going to pull from the library. Yes, downloaded new image for Nginx and it started my container. Once the container is started, let's copy this file, copy this IP, access it. So what it is saying that 403 forbidden Nginx server, it is, we don't have access for that. We don't have a access for that. Now let us see that what is the container which is running. Container ls. So can you see a container is running with the C1? What is the name I have given for the container? For the container, I have given the name as a C1. For the container, I have given the name as a C1. So it is running now. For the container, I have given the name as a C1. It is running now. Are you clear? Are you guys clear with this? I have given the container name as a C1. Now I am going to create one index.html. I can create in my local directory, in my present working directory, or I can go to the directory which we have created. Here I'm going to navigate to this location. I'm going to create vi index.html. So I'm going to make it as insert mode. Let me go to insert mode, h1. Welcome to Docker volumes. Welcome to Docker volumes. Save this file and close it. Guys, if you see where I have created my file, file is created in the local or file is created in the container. File is created in the local or file is created in the container. File is created in the local. Refresh. Is it reflecting now? Is it reflecting now? Earlier we got 403 because that is not available. That index.html file is not available. So now I created index.html. Where I have created the index.html? Where I have created index.html? Come on, guys. Where I have created my index.html? I created in the local. I created in the local. Then how it is reflected in the container? How it is reflected in the container? Come on. How it is reflected in the container? There is a mounting between our directory and container. There is a mounting between our container and directory. So whatever the files you store it to directory, they will be available for container. Whatever the files available in the container, it will be available for our directory. So there is a mapping, there is a mounting. There is a mounting. Are you guys able to understand now? Are you guys able to understand this mounting? So how many ways we can save container data? How many ways we can make our applications stateful in the Docker containers? Two ways. What are those two ways? What are the two ways? Come on. What are the two ways to make our applications stateful, which are running in the Docker containers? How many ways we can make our applications stateful, which are running in the Docker containers? One is by using named value. Second one is by using mounted directories. Mounted directory mounting to Docker container. Host directory mounting to Docker container. Can we mount one directory to multiple containers? Can we mount one directory to multiple containers? Yes, we can do that. Yes, we can do that. Okay, so create directory in host machine. Create directory in host machine. Create directory in the host machine. Run the Docker container for Nginx image. Run Docker container for Nginx image with directory mounting. Container name is C1. Container name I have given as a C1. Then see the container which is running. see the containers which are running. C1 should be run. C1 should be running because we have started. Go to mounted directory in the host machine. Go to, before going to this, access Nginx web server. Access Nginx web server using EC2 VM, using host machine public IP. That means EC2 VM public IP. Using host machine public IP. Host machine means the machine where our Docker is running. Access web server using host machine public IP. So index.html not available. It will not be displayed. It will not be displayed because index.html not available. It will not display because index.html not available in container. It will not be displayed because index.html file not available in container. Go to mounted directory. Go to mounted directory in host machine. Create index.html file. Create index.html file. Write the content and save it. vi index.html. So write the content. Write the content in index.html file, then save it and close it. Save it and close it. Now access Nginx web server. Access Nginx web server in browser. Changes will be reflected. Changes will be reflected. Note, we have created index.html file in host machine mounted directory. In host machine mounted directory. Host machine mounted directory, it is displaying, it is reflecting in container. So mounted directories we are able to use. Now let me go to this file vi index.html. Let's make some change to that file. h2. This is mount directory example. This is mount directory example. Let's save this file and quit. I am currently in the host machine. In the host machine, I have index.html. I'm making the changes to the file in the host machine. See here, it is reflecting in the container. So mapping is created between our EC2 directory and Docker container or not. Mapping is created between our EC2 machine and Docker container or not. Mounting is happened or not. If you create the data in the container, that container data will come to the local file. If you create the data in the file, that will be available to the container. Are you guys clear with my point? Are you able to understand host directory mounting to Docker container, named volumes mounting, host directory mounting? Named volumes mounting and host directory mounting. This is an interview question. They will ask you, how can I mount my host machine directory? How can I mount my host machine directory to the Docker container? That is called bind mount concept. It is called as bind mount concept. So I'm just creating one directory. I'm just creating one directory in my host machine. Then I am running a container. I'm mounting that. It is -v. It is a volume. Bind mounting that volume. Mount volume. Mount volume. -v. This is the location where I created the directory in the host machine. This is container location. Now I am creating a file. I'm going to this location. I'm creating a file in the container machine. Sorry, in the local directory machine, host machine. It is reflecting in the container. Any change you make in this directory will be reflected in the container. Any change that happened in the container will be reflected to our directory. There is a connection between our host machine directory and container. Connection between host to machine, directory and our container. Are you guys clear with my point? Are you guys clear with my point? Very good. So yesterday we have seen how to get the container locations and all, right? So you can execute this command. You can go to the container and you can see this location. This is the command that you can use, bash command. You can go to this location and you can make the changes to that file. So docker exe it, it represents interactive mode, container name bash, then go to this location, then make the changes to that file. Then you can understand that part. Are you clear with host directory mounting to Docker container, named value mounting, and host directory mounting? Perfect. Good. Good. So with this, we understood the concepts related to Docker. So can we summarize what we learned in the Docker so far? The next topic is damn important, guys. So real-time scenarios we are going to understand and the Docker. So before going to enter into that real-time scenario of the Docker, so I want to summarize what we learned here. So we discussed about what is virtualization, what is containerization, what is virtualization, what is containerization, virtualization, containerization, what is the Docker, what is the Docker, advantages of Docker, advantages of Docker, Docker setup, Docker setup, Docker terminology. Docker terminology. We discussed about what is Docker file, Docker file, Docker image, Docker file, Docker image, Docker hub, Docker hub, and Docker container, Docker image commands, how to see the images, how to pull the images, how to remove the images, how to prone the images, Docker image commands, and Docker container commands we have seen, how to start a container, how to do the port mapping, how to display all the containers, how to stop the containers, how to remove the containers, how to prune the containers, how to inspect the containers. Docker container commands we have seen. Then we discussed about Docker volumes, named volume, and binded mounted volumes, bind mount volumes also we have discussed. So this is what we learned so far in the Docker, and the most important thing is writing Docker file also we discussed. The most important thing we discussed here, writing Docker file. Writing Docker file. And we discussed about Spring Boot app Dockerization, Java web app Dockerization, Java web app Dockerization, Python Flask app Dockerization, Python Flask application Dockerization we have discussed. Did I cover all these topics so far? What is virtualization? So installing guest operating systems on the host operating system using hypervisor is called as virtualization. Installing guest operating systems on the host operating system to manage our application deployments is called virtualization. Some advantages are there and mainly disadvantages are more. So for that purpose, we are going for containerization. We are going to package everything as one image and we are going to run in the container. So easily we can run the Docker containers in multiple applications, easily shippable and easily deployable. So that's why the Docker symbol is also ship symbol. Easily we can ship our applications to multiple machines and we can run them. Advantages of the Docker we have seen, and Docker architecture we have seen. Docker architecture. So we are going to write a Docker file for our application. So with the Docker file, we are going to build a Docker image. That a Docker image we can store in the Docker Hub. We can pull the Docker image. In which machine you want to run your Docker container, you need a Docker image. Docker image basically a package which contains our application code and the softwares which are required. Image is just a package. So to create the image, we are writing the Docker file. So Docker file will follow DSL, domain specific language keywords will be available from keyword, maintainer, CMD, run, entry point, volume, arc, expose, right? Like that, there are several keywords available. We have seen what is the purpose of those keywords also. And we installed Docker in our Linux machine. Docker terminology we discussed. What is Docker file? What is building the image? What is Docker image? What is Docker container? What is Docker hub? And what are the keywords we are going to use in the Docker file? Docker images, Docker hub, containers, image commands, how to work with Docker images, how to work with Docker containers, how to see the images, how to pull the images, how to remove the images, right? How to start the container, how to see the container, how to stop the container, how to remove the container, how to prune the containers. Those things we discussed. Then we are able to write the Docker files also by using those keywords. Spring Boot application Dockerization we have done. Spring Boot is one of the concept in the Java. So Spring Boot applications will be packaged as a jar file. So you just need to take the Java as a base image and you need to copy the jar file and you need to run the jar file by using java space -jar. So that is only for Spring Boot. When you come to normal Java web application which doesn't have a Spring Boot, that normal Java web applications will be packaged as a WAR file. That WAR file we need to deploy to Tomcat server web apps folder. That WAR file we need to deploy to Tomcat server web apps folder. So in this normal Java web application, in the Docker file, we are going to take Tomcat as a base image and we are going to take the WAR file from the target and we will copy that into Tomcat web apps folder. Target file, in the target folder, we have a WAR file. We will copy the WAR file from our target folder to Docker image, Tomcat that web apps folder. Then after we have taken Python Flask application. So we are doing a Docker file. We created a Docker file for that Python Flask application. So Python Flask is a requirement for the Python. So we are going to download the Flask first. Then we are going to run that. For Python Flask application, base package is a Python software. We need the Python in order to run this. So we are configuring the Python as a base image for that. Then next one, we discussed about stateful containers, stateless containers. So what is the meaning of stateless container, and stateful container? Stateless containers versus stateful containers. What is the difference between stateless container and stateful container, guys? Can anyone tell me? Can anyone tell me what is the difference between stateless container versus a stateful container? Come on. Respond. Guys, I'm spending this much time for you. I'm discussing this much subject. When I am asking a question, you are not responding. If you don't respond, I will not get interest. I'm taking the class till 10 o'clock, 10:30, 10:45, up to 11 o'clock. I'm sacrificing my personal life also. So you have to realize that. So when I ask a question, you have to respond. When you respond, then only trainer will get the interest to discuss more subject. If you don't respond, then we will lose that interest. Outside, DevOps, AWS people are teaching for 3 months. But why it is taking 4 months, 5 months here? Are we compromising on the quality? Are we compromising on the quality? Now, can you imagine DevOps, AWS can be completed in 3 months? Now, can you imagine AWS DevOps can be completed in 3 months. And that too we are taking for DevOps daily 1.5 hour, 2 hours sessions per day. Still topics are pending. Lot of content is there. It is a master program on the DevOps. Tomorrow, once you get the job, you should not face any problem. You should not come back to again for training. With that intention, I am delivering this course. Tomorrow, once you join in the company as a DevOps engineer, you should not come to Amirpet once again to learn the course. This should be your last course as a DevOps cloud engineer. With that intention, I am delivering this content. If I just want to finish the batch within 3.5 months, 4 months, we can finish. All topics will not be covered. Yeah, you wasted so many years of time. If you spend 1 month extra for learning, there is no problem. People are asking when the course will be completed. You need to concentrate on the quality, not on the duration. Yeah, duration is also important. If I am wasting your time, if I am not taking the classes regularly, then you need to worry about the duration, right? Today I got a message from a student when you are going to complete the DevOps. If you want, I can complete by next week. If you want me to complete the syllabus, I can complete by next week. What is the benefit? Who will get benefited if I complete the syllabus by next week? If course completed quickly, who will get benefited? You will get benefited or I will get benefited? If course completes quickly, I will get benefit. Because if this batch is completed, we will start one more batch. Then new people, new payments, more money. But we are not looking for that, guys. We are giving the quality. So you need to spend the time if you want to get that quality. Okay, fine. All right. So Muhammad, Docker Kubernetes 1 month. Daily, if it is 1 hour, it is 1 month. But daily, am I taking 1 hour or I'm taking 1.5 hour, 1 hour, 45 minutes and 2 hours per day? It will take 1 month if we take only 1 hour class per day. But am I taking 1 hour for Docker? Daily, more than 1.5 hour, almost it is going 1 hour, 45 minutes, 2 hours of time. So when the class duration is increasing, number of days are going to decrease. So you can understand that. All right. So what is the difference between stateless container versus a stateful container? Stateless container means we are going to lose the data which is generated by that container. We are going to lose the data which is generated by that container. By default, all the containers are stateless containers only. So whenever the Docker container got created, so it will generate some data. It can be a database or it can be a log file or it can be some files, whatever it is. Whenever the container got started, it will generate some data. That data will be stored within the container. That container is by default stateless container. When you stop that container, we are going to lose that data. But I don't want to lose that data. I want to make my container as stateful container. What is the meaning of stateful container? I want to store the data permanently. Even if that container got deleted, I want my data. Even though container got deleted, I want my data. So can we make a Docker container as a stateful container? By default, every Docker container is a stateless container. I want to make the Docker container as a stateful container. So guys, do you know how to make a Docker container as a stateful container? Do you know how to make the Docker container as a stateful container? How to make it? How to make it? By using volumes concept. How many ways we can work with volumes in the Docker, and what is the purpose of volumes in the Docker? Volumes are used to store the data. Volumes are used to store the data which is generated by Docker container. So Docker volumes concept available. We can create a volume. We can mount the volume to Docker container so that container data will be stored to the volume. When the container got deleted, we will have the data in the volume. That volume we can attach to another container and we can get the data. We can share the data from one container to another container by using a concept called volume. Can we mount the volume to multiple containers, guys? I will create one named volume. Can I mount that volume to multiple containers? Yes, we can mount the volume to multiple containers. We can mount the volume to multiple containers. So that is a named volume. So instead of going for a named volume, can I mount Docker container to a host machine directory? Can I mount Docker container to host machine directory? Come on, guys. Yes, so we have done binded mounting. That means I have created one directory in my machine, in a host machine. In that host machine, I created one directory. The directory I mounted to my volume by using -v. So Docker run -d represent the detached mode. -p represents port mapping for that image, that container which is running. Nginx image will run by default 80. So in my host machine also I am mapping to 80 port. -v is the volume name I am specifying. I'm not using a named volume. I'm giving my mounting location in my local machine that is mounted to container location. So whatever the data I store in this directory, it will be reflected to container. If we make any changes to this location in the container, that will be reflected to our mounted. So this is mounting Docker container to host directory. Good. With this, we completed our discussion related to Docker volumes, named volumes, and binded mount volumes. Binded mount volumes also we covered. All right. Fine, guys. Good. Now, let's talk about real world applications. 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 Okay. Now, guys, applications can be developed in two ways. One is by using monolith architecture. Another one is microservices architecture. So already we discussed in the AWS at the time of load balancing, what is monolith architecture application and what is microservices architecture application. So now what is the meaning of monolith architecture? What is the meaning of monolith architecture? Can anyone tell me? What is the meaning of monolith architecture application? Come on, guys. What is the meaning of a monolith architecture based application? Respond quick. What is the meaning of monolith architecture application? Everything will be part of one project. Everything will be part of one project. Okay. For this project, I am going to create one Docker container. For this project, I am going to create one Docker container. This project will be executed in one Docker container. So we know already how to write a Docker file. By using the Docker file, we can create Docker container. So here, how many containers we need to run this application now? One container I am taking to run this application. So this is monolith architecture. But in the real time, currently, applications are monolith architecture based. Applications are microservices architecture based. It is a monolith architecture based application. In order to run this monolith architecture based application, one Docker container is sufficient. One Docker container is sufficient. But nowadays, in the real world, applications are developing by using microservices. So this is products API, and this is cart API, and this is payment API, and this is tracking API. So like this, I'm going to take several microservices for one application. So this is products API, and this is cart API. This is cart API. This is payment API, and this is tracking API, products tracking API, or shipping API. We can say that anything. Tracking API. All these APIs are belongs to one project only. That project is an e-commerce based project. So let's take an example of a Flipkart. So in the Flipkart, we can see the products. We can add the products to our cart. We can do the payment for the products. We can track our order. All right. So when you go for monolith architecture based application, we created one container and we are executing our application. But in the real world today, applications are developing based on microservices architecture. One application is divided into several sub applications. Facebook is one project to see one application, but inside the Facebook, several APIs will be available. Every API will be developed as one project. In order to run this API, I need one container, Docker container required here. In order to run the products API, I need one Docker container. For only products API, I need one container. For cart API, I need another container. For payment API, I need one container. For a tracking API, I need one container. So every API is going to run in a container. This is containerization based application. So now for monolith applications, we are taking one container to run. But for microservices based applications, one container will be available or multiple containers will be available. Single container based application, or I can say monolith application. I can say it is a monolith application. All right. And it is microservices based application. Microservices based application. Come on, guys. Now tell me which one is easy to deploy. Which one is easy to deploy? Running one container or running multiple containers is easy. For every API, we need to create one Docker file and we need to build one image. We need to create one value and we need to run our container. So here, single Docker file we are going to create and we are going to build a image and we are going to run the container. For monolith application, it is very simple, straightforward. Single application is available. Every functionality is available in one project only. For that project, we are creating one Docker file. By using that Docker file, we will create a Docker image. Using that Docker image, we will run the Docker container. It is very simple and straightforward when you go for monolith application. But in the real world, applications are monolith or applications are microservices? Applications are microservices. Applications are microservices. So if you go to one application, let me stop my Docker server, that I don't need it now. I will do okay, let's keep it running, no problem. Okay, let me go to one application which is called Make My Trip, or Facebook or Flipkart, anything, one application I'm taking. So if you go to the Make My Trip, flights functionality is available. If you click on search, flights data is coming. Flights is one API. Hotels functionality available. I can search for the hotels. Hotels is one API. And trains available. Trains functionality available in the Make My Trip. I can search for the trains. And buses available. I can search for the buses. So all these are implemented as microservices in the Make My Trip. Microservice is one big application, but that application is not implemented by using monolith, because monolith applications are very difficult to maintain. So that's why definitely This application implemented using microservices architecture. What is microservices architecture? The whole project, the whole functionality of the application divided into several sub projects which are easily maintainable. Set of APIs will be available. Every API is one application. So for every API, we are going to run one container. If you go for e-commerce, products API, cart API, payment API, tracking API. So for every API, we need to create a container and we need to run that application. Suppose, for example, if I have 100 APIs, guys, if I have 100 APIs, imagine 100 microservices are available for my application. For example, make my trip having 100 APIs. 100 APIs, nothing but 100 projects available. Microservice is one, that make my trip is one application. That application having 100 microservices. So now, how many images you need to create? How many containers we need to run? Can you tell me how many images we need to create and how many containers we need to run now? 100 images we need to create, 100 containers we have to run. Is it easy? Is it easy to run 100 containers? How many commands we need to execute? How many commands we need to execute to run the containers here? First, we need to build the image. Then we need to create the container by executing the lot of Docker commands we need to execute here. Lot of Docker commands we need to execute here. Now, is it easy or it is difficult? Is this concept is easy or this concept is difficult? Guys, come on. This concept is easy or this concept is difficult? This concept is difficult concept. This concept is difficult concept. So Docker should provide a solution for this or not? Docker should provide a solution for this or not? Hooray, in the industry, people are developing the projects by using microservices architecture. One project can have 100 APIs or one project can have 200 APIs. So if your project is having 100 APIs, creating 100 images, managing 100 containers separately is very, 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 very difficult process. So we need a solution where I can manage multiple containers with a single command. Now I am running a container. One container is starting. If it is a monolith application, that command is fine. I can create a container by executing docker run command. But my application having 100 containers. My application requires 100 containers. Do you want me to execute a docker run command for 100 times? To run 100 containers for 100 APIs? Do you want me to run docker run command for 100 times to run 100 APIs in 100 containers? Is it easy? Is it easy to create 100 containers by using docker run command manually? It is difficult. It is difficult. To overcome this problem only, Docker introduced a concept called Docker Compose. What is the concept, guys? What is the concept we are going to learn? Docker Compose. So guys, if you observe always, first I'm explaining the problem, then I am going for the solution. Then you can remember that concept for a long time in your mind. First I'm telling you the problem, then I'm going for the solution. Are you understanding this teaching pattern? If I directly tell you what is Docker Compose, you may not get it. So first I'm introducing the problem to you. For that problem, I am telling the solution. So this is the right way to inject the subject into your brain. This is the right mechanism, I feel. Correct approach. All of you okay with this? Yeah. Now, what is this Docker Compose? Docker Compose, it is a tool. It is a tool which is used to manage multi-container based application. What is the Docker Compose now? Can you guys tell me what is Docker Compose now? Docker Compose is a tool which is used to manage multi-container based application. What is the meaning of multi-container based application? What is the meaning of multi-container based application? In order to run my application, I need multiple containers. In order to run my application, one container is not sufficient. I need to go for multiple containers. Okay. So real world applications. In real world, we are going to develop in real world, applications are developing. Applications are getting developed using microservices architecture. One application contains several APIs. In microservices architecture, several APIs will be available. Every API is a project. Every API is a project and it should run in a container. So running containers for all the APIs manually is a difficult task. Running multiple containers manually for all APIs is difficult job. So to avoid to manage these multi-container based applications, to solve this problem, Docker Compose came into picture. Right? What is Docker Compose? Docker Compose is a tool which is used to manage. Docker Compose is a tool which is used to manage multi-container based applications. Multi-container based applications. Are you guys clear with my point? Using Docker Compose, we can define and deploy multi-container based applications. Using Docker Compose, we can define and deploy multi-container based, multiple containers or multi-container based applications. My application requires more than one container. It can be a 10, it can be 20, it can be 50, it can be 100. So running all the containers one by one manually is very, very difficult job. So in order to reduce that problem, we have a concept called Docker Compose. So in the real world currently, every application is getting executed by using developed by using microservices architecture. Microservices architecture means several APIs will be available. Every API is one project. So for every API, one container we need to create and we need to execute that container. So creating images and creating containers, running these containers manually is difficult. So in order to simplify how to deploy multiple containers for our application, Docker Compose concept came into picture. So in the Docker Compose, we are going to create one YML file. In that YML file, we will specify how many containers it has to create. For example, for my application, 4 containers are required, 4 images are available. For 4 images, 4 containers should be created. So you no need to create the 4 containers by using run command manually. You can tell to Docker Compose how many containers you want to run for your application. Docker Compose will create that. So you just need to tell to Docker Compose how many things that you want, how many containers you want. That information you need to give to Docker Compose. Then Docker Compose is going to set up multiple containers which are used to run your application. Are you guys clear with my point? Are you guys clear with my point? We will give input to Docker Compose using YAML file to run multiple containers. We will give input to Docker Compose using YAML file to run multiple containers. Okay. So now, so what we are going to specify in that YML, Docker Compose YML contains all the information related to our multi-container configuration. Docker Compose YML file should have information related to all related to all our services. Whatever we need, how many containers we need, how many images we have, what containers we need, what volumes we have, what network we have, everything we need to specify in the Docker Compose file. So Docker Compose file is a YML file. In that YML is readable, both human readable and machine readable. So in the YML, we will represent the configuration in the form of key value. We have already seen Ansible YMLs, right? So similarly, Docker Compose YMLs also we are going to write. So in the Docker Compose YML, we are going to specify what services we need, a sample Docker YML, sample Docker YML, sample Docker Compose YML, sample Docker Compose YML. The file name will be Docker Compose.yml. So in this Docker Compose YML, we are going to specify the version, which version we are using, what are the services we want to use, what is the network that we want to use, and what are the volumes that we want to use. Docker network concept. As of now, we have not discussed about the Docker network. In this Docker Compose file, we are going to specify which version we are using and what are the services, basically our containers, images which are we need to run. So if you have 10 images, so 10 service, you are going to configure the 10 images details in the services. So for those 10 images, 10 containers it is going to create. Docker network, it is currently a black box for us. We don't know what is Docker network. I will discuss Docker network in the coming classes. And volumes, already we know. Volumes are used to make our containers stateful. Multiple containers we are running. For all the containers, I want to use a single shared database. So that I'm going to specify as a volume. So like this, we are going to write Docker Compose YML. So Docker Compose YML contains information about our multi-container based application. Okay, now here some commands will be available for Docker Compose. So create and start the containers. So Docker Compose file name, Docker Compose file name, Docker Compose file name. You can give anything, but basically in the companies we are going to follow Docker Compose.yml. It is easy for readability. Docker Compose.yml. Once we have created the Docker Compose YML, in that Composer YML, we are going to specify how many containers we need to create for our application. So create and start the containers. We can change the name also, no problem. Create and start the containers. Create and start the containers. For that, what is the command? Docker Compose up. So if you give up, that's it. It is going to take this Compose YML. In this Compose YML, whatever the configuration we have created. So if you configure 10 images, for the 10 images, 10 containers it is going to create. Docker Compose up to create and start the containers. So based on the images we configure, it is going to start it. Okay, now list the containers. So which is running? List Docker containers. List Docker containers started by Docker Compose. For this, we are going to use $Docker Compose -ps, Docker Compose PS. What are the containers are running by the Docker Compose? It is going to display. So if you want to list all the containers, we can use PS. Stop and remove the containers. Stop and remove Compose containers. So for this, we are having a command called Docker Compose down. Up is used to create the containers based on your Compose YML. Down is used to stop the containers. Are you guys clear? Clear with my point? To list down the images, running services images, we can go for Docker Compose images. List down running container images. What are the images it is using? For that, we can go for Docker Compose images. Docker Compose images, we can use it. So like this, there are several commands are available. So using these commands, we can run it. So if you have a use different file name, using different file name, if your file name got changed, then you can specify Docker Compose -f file name up or down. You can like this, you can use it like this. So I want to start the containers by using this Docker Compose file. So the default for Docker Compose default file name, the Docker Compose default file name, docker-compose.yml. In this Docker Compose file, we are going to write version, we are going to write the services, we are going to write the network, we are going to write the values. So in under the services, I'm going to specify I want one image for product API image, cart API image, like that. Multiple images which we have, we want to run multiple containers for our application. All those things will be configured under services, right? Network, we don't know, we will talk about that. Isolated, if you want to run the containers with isolation, then we can go for network, it's right. Volumes, for making the containers as a stateful, we can go for volumes concept. So what is the main purpose of going for Docker Compose? Real world applications are developing using microservices architecture. So multiple applications will be available. For multiple applications, multiple containers should be created. Creating multiple containers and running them manually is a difficult process. So to simplify how to build and run multi-container applications, we have a tool. That tool is called as Docker Compose. Docker Compose is a tool. It is used to Docker Compose is a tool which is used to manage multi-container based applications. Using Docker Compose, we can define and deploy multi-container based applications easily with a single command execution. That's it. We will give input to Docker Compose tool using YML file to run multiple containers. So Docker Compose.yml file will be available. So YML means key value pair. In that YML file, we are going to write our configuration. So the default file name is this Docker Compose.yml or YAML also you can use it. So once you configure your Docker Compose YML, then you can use this command Docker Compose up, which is used to create and start the containers based on the configuration available in the Compose YML. So if you go for Docker Compose PS, it is going to list down the Docker containers which are started by Docker Compose containers. If you want to stop all the containers, then Docker Compose down. Up means start, down means stop. Docker Compose images, the images which are using by the running Docker containers. If you want to use a different file name for the Docker Compose, this is the default file. I don't want to go with the default file. I want to use a different file. Then I will specify Docker Compose -f, this file name. I can give up. It is going to start containers based on the configuration which is available in this Docker Compose file. Are you guys clear? Are you guys clear? Yeah, few more commands also available related to Docker Compose. I will prepare a cheat sheet for this Docker Compose commands. So very basic commands that I have listed down here. So to give you a brief introduction related to Docker Compose. Guys, you understand why we are using Docker Compose? Now tell me in the real time, will anybody use only Docker without Compose? Will anybody use only Docker without Compose? No. For every application, multiple containers are required. So here, if you go for monolith application also, multiple containers are required. Why? Application will be running in one container, database will be running in another container. I want to run my application in one container. I want to run the database in the another container. how to do this by using Docker Compose. Okay. So can we do one small exercise on this Docker Compose? Can we do a small exercise on the Docker Compose? Yes. So we need to set up this Docker Compose in our system. We need to, by default, it will not come along with the Docker, guys. So we need to set up this Docker Compose. We need to set up the Docker Compose in our system. We need to install this Docker. We need to install this Docker. So Docker Compose we need to install, guys. So in order to install the Docker Compose, so I'm going to take some set of commands. Docker Compose setup. Docker Compose setup. Right? Yeah. So we need to download a file. We need to download a file by using this command. You can download that file. Once you have downloaded, give the execute permission for that. Then you can check the version. Okay. So it's very simple, a two-step process. So setting up the Docker Compose in our machine, Docker Compose setup, download Docker Compose. So by using this sudo curl-l, I'm going to hit that URL. I'm going to hit this URL. It is going to download that. And once it is downloaded, I'm downloading to this particular location. So this is the location where I'm downloading. So for that directory, I'm giving +X permission. Then I'm going to check the version. So here my machine is available. First, let me check the Compose version. Is the Docker Compose available or not? Command not found. Guys, am I able to check the version of the Docker Compose in my machine? It is saying that command not found. So what is the meaning of command not found? What is the meaning of command not found? That is not installed. Right? Let's do this. Install it. I installed it. Once it installed, then give the permission to that location which I have given. Give the permission. Yes, I have given the permission. Then compose Docker Compose -version. Yeah. So can you see the Docker Compose version 1.2.4? Are you guys able to see the Docker Compose version? Are you guys able to see the Docker Compose version? Come on, guys. Yes, we are able to see that. Now, I want to do some exercise on this Docker Compose. So I want to take one sample Docker Compose YML. In that, I want to set up my application. I'm going to use two containers. So one is for database. One is for database. Another one is for some PHP or WordPress based applications I want to set up. Okay. With the WordPress container, with the MySQL database, I want to set up a Docker Compose. See this. So once this is a basic example I'm taking with WordPress and MySQL. Once we are clear with this, I will go for Spring Boot with the Mongo database, Spring Boot with the MySQL database. I will show you real world applications also. Now, I want to create one container for MySQL database. I want to create one container for MySQL database container. Good. And I want to create one more container for PHP WordPress. WordPress is used to develop our websites, beautiful websites we can build by using WordPress. So for this, I want to create one WordPress container. This WordPress container want to use this MySQL database. So I want to establish the link between WordPress container and MySQL database. So these things I will create by using Docker Compose. So is it the real purpose of Docker Compose or not? Creating and managing multi-container based application. I want to set up one WordPress website. I want to set up one WordPress website by using Docker Compose. So to set up the WordPress website, I need to run WordPress. For that, one container I need, and I need to run the MySQL. For that, I need one container. So tomorrow, when we go for Java based application, what will happen? Java application container will be available. Java web app container will be available. Java web app container for running our Java web application. To run our Java web application, this web application want to communicate with Redis cache, and it want to communicate with database also. Two containers I need, right? One is Redis container. Another one is MySQL DB. Redis and MySQL DB. So total 3 containers I need for this application. Single application needs 3 containers. So Java web application container, Redis container, and MySQL DB container will be available. This is how the real world applications will be developed. So one application requires multiple containers. Managing multiple containers separately, individually is difficult. Now my Java application container should communicate with Redis container, and it should communicate with MySQL container also. This we can manage by using Docker Compose. Multi-container based application. Are you clear with my point? Why we are going for Docker Compose and what is the purpose of going for Docker Compose? Are you clear with my point? Come on. If you go for microservice architecture also same, multiple containers will be available. This is one API container. For one API, I need 3 containers. So if I have 10 APIs, 10 into 3, like that. So multiple containers we need. Okay. So here, product API need one container, and product API need a database also. Then database will have another container. Database will be running in another container. Redis cache is required. Redis cache is running in another container, like this. Okay. So here I am having DB container, and here I am having Redis container. DB container and Redis container. MySQL DB. Database container. Database container I need, and here Redis container I need. Okay. So for every API, one container is available, and they should talk to DB container, and they should talk to Redis container. Got it? Like this. Multiple containers I want. So this container should talk to DB container. This DB container talking to this product API container talking to DB container. Cart API also talking to DB container. Payment API talking to DB container. Tracking API is talking to Redis container, like this. So there is a dependency. One container want to talk to another container, there is a dependency. So that we can manage by using Docker Compose. So when we have multiple containers like this, managing these containers individually is difficult because one container is dependent on the another container. It is difficult to manage. If it is a single container, we can manage easily. But if you have a multiple containers, difficult. In the monolith application also, we are going to take DB container. For monolith also, application container is available and DB container is available. Now this Docker container should talk to, app container should talk to this DB container. App container is available. App container should talk to DB container. Here also multi-container required. App container. So for this monolith application, app container is created. For that, we need a DB also. DB is running in another container. Database is running in one Docker container. Application is running in one Docker container. Application container should talk to DB container. So here also multiple containers. Here, so many containers. If you go for monolith, 2 to 3 containers will be available. If you go for microservices, so DB container is available, Redis container is available. Redis is a cache container, database container. And for every API, one container. So lot of containers we need to execute. One container is dependent on the another container. Managing all these containers is difficult. So that is the reason we are going for Docker Compose. So in future, we are going to understand this also, but currently I'm going for this MySQL database as one container, WordPress as one container. I want to create and manage these two containers, WordPress container, MySQL container, by using Docker Compose concept. So once this MySQL WordPress is completed, then we can experiment with Java MySQL database. Java application in one container, or MySQL DB or MongoDB in another container. Multiple containers I want to manage by using Docker Compose. Are you clear, Akhil? What is multi-container based application and how to manage multi-container based applications by using Docker Compose? Very good. Now let's go here, guys. Create a Docker Compose file for setting up dev environment. MySQL container is linked with WordPress container. So this is my Docker Compose file. So already we have installed Docker Compose, Docker Compose version. It is displaying Docker Compose version 1.24 is available, ls-l. So let me delete this file. Let me go back to my home directory, cd /home ec2 user. I'm going to my home directory, ls-l, rm index.html. Yes, ls-l. Currently, nothing is available in my home directory. I'm going to create one YML file, that is Docker Compose YML. So I told you in the Docker Compose file, we are going to have several things like version will be available, services will be available, network will be available, volumes will be available. So currently here, I'm taking just version and service. Remaining things we are going to practice. What is that volume and what is that network? We will discuss in the upcoming classes. So currently I'm taking services. In the services, I specified two containers. One is MyDB and another one is my site. My site I'm specifying as one image. My site is I'm specifying for one container. MyDB I'm specifying for one container. So under services, I configured two services. So this MyDB should be one container. My site should be one container. So MySQL database should run as one container and WordPress should run as one container, and WordPress container having a link with a MySQL container. That means, so this my site container is linked with MySQL. We will discuss how to write this compose YML file also in the tomorrow session, how to write these services, how to specify our image names, how to establish the link from one service to another service. We will discuss in the tomorrow session. So currently I'm just giving you a demo how the Docker Compose is going to execute. So Docker Compose YML services available, MyDB one service, which is specifying that MySQL database should be started as one container using MySQL image. My site I'm specifying as another service. In my site I'm specifying image name as a WordPress, and this my site having a link with MyDB MySQL. All right, port number 80, and this WordPress is going to run on the 80 port. I am binding that to 5050. You can bind it to any port number. This left side is the host machine port, right side is the container port. Container is going to run on the 80. I want to bind it to 5050, or I can bind it to 9090, whatever I want. Host port number is our wish. This container port number is fixed value. Host port is our wish. So this is Docker Compose.yml. Before going to do this, can you see Docker PS? One image is running, one container is running. Docker stop this container. Docker stop this container. Docker RM, that means remove that container. Then Docker PS. So now check it. So do we have any container running? No. Docker images. So Nginx image is available, guys. So we can delete that also. Docker RMI-F Nginx. That is also deleted. Docker images, no images available. Docker PS, no containers are available. Now let me create my Docker compose file, docker compose.yml. I'm going to just copy this YML data. So services, MyDB is one service for MySQL. My site WordPress is available as this. So 80 is the port number of container and 9090 is my host port, version 3 I'm specifying. Quit. Yes, my compose is ready, which will manage two containers. One is database container, another one is WordPress container. Right. So once this container is ready, once this compose is ready, what is the next step we need to do? What is the next step? How to start the containers from the YML file, docker compose up. It is going to create all the containers. See here, pulling MySQL DB, pulling MySQL. It is pulling MySQL database. Then pulling WordPress. Can you see? Pulling MySQL and pulling WordPress. How many containers it is going to create now? Is it creating one container or it is going to create two containers? Two. One is MySQL container, another one is WordPress container. One is MySQL container, another one is WordPress container. It is setting up. It is setting up. It is done. It is done. Okay. Once it is done, if you want, you can stop them. You can remove all the containers which are running. Then if it is done, we are running our application. We are running this with 9090 host port. Go to our host machine. Check it. 9090 port is enabled in the security group. Which is security group? Ashok IT security group is enabled here. We used it. Okay, we logged out from this AWS root account. Go to this sign in. Security group ID 9090. No, it is not enabled. Let me enable 9090 because host port I mapped to 9090. Click on save it. Yes, we have enabled. Then go to EC2 dashboard, access this machine public IP with a port called 9090. Can you see WordPress site is ready? Can you see WordPress site is ready? Select the database, database username, database password, host name. Like this we can configure username, database username. You can configure username, password like this, database host name, table prefix like this. We can set up our WordPress site. We can set up our WordPress site. So MySQL database we configured and WordPress we configured and we are able to access that application. So once it is done, once we are able to access it, once we are able to access it, right? If you want to stop the both containers at a time, then we can go for Docker compose. So here we are done with this. We are stopping these containers. Control C again to force stop it. Okay, Docker PS. So containers are stopped. Control C I pressed. My site is created. MySQL container started. WordPress container started. Two containers got executed and I stopped them. So you can use Docker compose stop or just to stop the containers. If you want to stop and delete them, down is available. Docker compose down is available to stop and remove the containers. If you just want to stop the containers, Docker compose stop, you can use it. So are you able to understand how I am managing two containers by using Docker compose? How I am managing two containers by using Docker compose? Good. So I want you people to practice this Docker Compose before coming to tomorrow's session. So in the tomorrow session, I will tell you how to use the Docker Compose for Java application with MySQL database. Java application will run in one container. MySQL database will run in another container. How to establish mapping between one container to another container. How to manage two containers by using Compose, that I will discuss in tomorrow's session. Good. Yeah. So tomorrow I will complete the discussion related to Docker Compose. Then we will start Docker network concept. Thank you guys. We'll see you in tomorrow's session.